This video is on the pH scale, what it is, and how to calculate it. So you've probably heard of this pH of things. You can see examples of it. It's a scale that runs from 0 to 14, and it's a measurement of how acidic or basic a substance is. So looking at this, you can see neutral right in the middle is a pH of 7, and that would be pure water. So like distilled water like we have in the lab. So acidic is going to be to the left of that, anything less than 7. So milk is slightly acidic. Coffee, tomato juice, vinegar, lemon juice, stomach acid, battery acid. The further away you get from 7, the more acidic it is. So battery acid is a lot more acidic than milk. On the other side of 7, so greater than 7, are things that are basic. So the opposite of an acid. Basic things are things like your blood is slightly basic, baking soda, milk of magnesia, which would be like something you might take if you have an upset stomach. Tums and things like that would fit in that area. Ammonia, like a cleaning product, soap, bleach, and sodium hydroxide. So bases are going to be things that contain hydroxide, right? Remember, is that OH minus? Acids are going to be things that contain hydrogen. Okay, so H plus 1. So pH is temperature dependent, meaning it will change if the temperature changes. So all the pHs we're going to be talking about and the scale and the values and all this are at 25 degrees Celsius, which is about room temperature. This is, for your reference, 77 Fahrenheit. Okay, so how do we calculate this? How does this kind of relate to if I'm just given an acid, for example? So equations to note are this. To calculate the pH, and it is a lower p and a capital H, it is the negative log of that H plus concentration. So we just talked about concentration, right, is the moles per volume of just the acid, so the hydrogen, and you just have to type this in your calculator, okay? So pH is related to something also called pOH. So I'm going to add this into this part. So this scale right here, this is our pH scale, okay? pOH is the opposite. So pOH is at 0, it's 14, okay? At NaOH in this case, or 14, it would be 0, and 7 is still in the middle. So, so this right here is our pOH scales, right? So 13 would be where 1 is, right? 13 down here would be 1 on the pOH scale, and so on. So you can see, like, every time I have a pH of, let's say, 1, I have a pOH of 13, right? If I had a pH of 4, I would have a pOH of 10. These corresponding numbers will always add up to 14. So they're just reverses of each other. So pOH plus pH is 14. And the reason this is important is because sometimes we don't have the H plus concentration because we don't have an acid. Sometimes we have a base. So we're going to have a pOH concentration. So pOH needs to be calculated. And pOH, just like pH, is the negative log, but it's the OH minus concentration instead of the H plus concentration. So these are the 3 equations we're going to use. If your H plus and your OH minus are equal to each other, that would be something that is neutral. All right, it would have a pH of 7. If you have more H plus, if your H plus is greater than your OH minus, that would be something that's acidic. You have more acid. And if your OH minus is greater, that would be something that's basic. You have more base. All right, so let's do some calculations with this. So if our H plus is 1 times 10 to the negative 3rd, calculate the pH. All right, so I'm going to use that equation in purple. So pH equals the negative log of, I'm going to just put it in parentheses, 1.00 times 10 to the negative 3rd. All right, so remember how to type this in your calculator. your scientific notation, that 1 times 10 to the negative third, that this part right here, that's the EE button or the EXP button, and then -3 because that's our exponent. So I'd type in 1, I push that EE button on my calculator, -3. The log, you're gonna have to find the log button. Some calculators you have to type log first, like you'll just go left to right. Some calculators you have to type it after you type in the numbers. So you're gonna have to practice with your calculator. And then don't forget the negative. So when I type this one in, I get 3. Okay, so what does this mean? Well, if a pH is 3, go back to here, right? So let's kind of erase some of this stuff. pH of 3 means we have something that is acidic, right here. Okay, so I'm just going to make a little note that that's acidic. It's always good to know what it means, okay, because our pH is less than 7. All right, so now let's do the reverse. If our pH is 8.67, calculate the H+. All right, so how do I reverse a log? Well, log is, if you remember from math, log is base 10. So log of x equals a if we just make a generic form. So to undo a log, I take that base 10 to the answer, 10 to the a equals x. So for this case, it'll be H plus equals 10 and to the pH, and it's a negative pH because of our negative log. All right, so it's just a matter of plugging it in. So our H plus concentration is 10 to the negative 8.67. And I'm actually going to type this in and get the actual value in my calculator. So when you type this in, you get 2.14. Don't forget the n. You should see the exponent way at the end, times 10 to the negative 9th. And this is a concentration. pH doesn't have a unit, but concentration does. This is moles per liter. And if I said, is this acidic or basic? Well, I would hope you'd say this is basic because the pH is greater than 7. Right? It said it was 8.67. All right, one more. All right, so if our H plus is this 3.5 times 10 to the negative third moles per liter, now we're going to find the OH minus the pH and the POH. All right, so let's first, I think the easiest, the only one we can really do is this. Let's start there. So pH, just like we did in the first example, pH is the negative log of our H plus. So 3.5 times 10 to the negative third. So I type this in and I'm going to get a pH of 2.46. All right, we got one thing. All right, next I'm going to go from there. If I know my pH, I can use this equation in green and find the POH. Okay, so the pH and the POH add up to 14. So the POH is going to be 14 minus the pH. So in this case, 2.46. So our POH is 11.54. Remember, because these two have to add up to 14. Okay, so that's next. The last part then is how do we find the OH minus? Well, if I know the POH, I can find the OH minus, just like I did with the H plus. We can undo this log. So the OH minus is going to be 10 to the negative POH. So OH minus is going to be 10 to the negative 11.54. And I type that in and I get 2.89 times 10 to the negative 12. And remember, this is a concentration, so this has units of moles per liter. All right, so we used all the equations. Last part of the question is this solution acidic or basic? Well, the easiest way to do it is to look at the pH right here. The pH is less than 7, so this is acidic. Our OH minus concentration is greater than our our H plus concentration is greater than our OH minus concentration is another way to look at it, right? 3.5 times 10 to the negative third is greater than 2.89 times 10 to the negative 12. So that is pH and how to calculate it.